So I've started by removing all of these hard-coded values for the NOP going into data. So really at this point I pulled those wires, and I want to pull out these SIPs. We won't be needing those. And then up here I have S1, S0, and then I've got the COD int A and the MIO LEDs. And really I want to get those moved and put them in order that matches the order on the documentation for the processor, which lists it as the COD int A first, MIO, S1, and S0 in one of the tables that I referenced in the last video. So I just want to swap that around so that I don't have to do the mental gymnastics every time I'm looking at the LEDs. I just kind of want them in order. So that's what I'm going to do here, is real quickly move these LEDs around with the COD int A being the first one. And so let me go ahead and do that. Okay, that order now should be in the order that matches the table. So COD int A, MIO, S1, S0. So this will help me be able to cross-reference that table more quickly. So the next thing I'm going to do is add in my two flash chips here on the breadboard and start to wire those up. So I've added the HC21, which is the AND gate. Also have the HC20, which is my NAND gate. Those are both 4 input. And then I have an inverter up here, an HC14 that I'll be using. And I'm going to go ahead and wire up the address lines and that logic accordingly. So at this point, as I'm looking at the output here, we got the indicator that my ROM, my flash ROM should be being read right now, which of course means that over here I'm expecting to see the NOP value, and that apparently isn't the case. So now I've got to figure out why that is the case. If it's something wrong with my design, or I just have in my mess of wires here something missing. So I'm going to just start going through the signals that I would expect to see and figure out what's going on here. So if I get down here to my LSB, so my least significant byte, and I start looking at the values, I can just make sure that we've got the right value, which should be that value here, making it to my ROM. So I'm just going to pull up the pinout on my computer off to the side here, and we've got 18. It's high. The mic might not be picking that up, but this is a high, this is a low. So I've got a high in 18, 16, 15, 12, 7, 6, 5, 4, and that is just a little piece of a wire there that I'm going to pull out, or just push it out of the way at least. Just wire insulator there. Okay, so then we get high, high, high. Okay, this one's low, and that was the fourth data pin in, so that'd be 0, 1, 2, 3, which we would expect to be low, 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 low. So that should be my 3 lows. So now I'm going to come across and read the rest of these and make sure they're all highs. So any of the blue wires are address wires. Okay, so I've got all 1s to this, minus the lowest 4. So that all looks good. Let's just make sure I got power here, got ground here. That looks good. Write enable is high. That's an active low, so I don't want to be writing, so that looks good. Output enable is pin 24, and that pin 24 then we want to be low at this point. That's the expectation. So output enable, that would get me to right here. So that is low. Let's make sure I got the right one there. And got chip enable. Okay, so I think I'm just looking at this. We should be going 5 data lines, 1, 2, 3, 4, 5. Then we should have a CE, not an A10. So this I appear to have miswired right here. So CE should be pin 22, 17, 18, 19, 20, 21, 22. So my CE should be this one right here, and I've got it in the wrong spot. Let's double check over here too. 17, 18, 19, 20, 21, 22. Okay, so that one looks like I got it in the right spot. So we go yellow, then we've got an address, and then we've got the black. So yellow, these two I've got swapped. So I need to swap those two around, and I'm going to do that here real quickly. So this one I'm going to just pull off to the side temporarily, and I'm going to get my ground here, and that should be 2 over from the yellow, like so, and then this one should be between the yellow and ground. Okay, and now this obviously looks much better. The value that I'm looking for there is 90 in hex, and that would be my 90 in hex. So that looks good. So that means I am pulling up my NOPs from flash at this point. So that's great. So just walking through this again, maybe what I've done, let me just recap that. I rearranged the LEDs up top. So this first LED is simply telling me, is my flash currently being read? In other words, all that logic that I put in with these chips, the AND, the NAND, and the inverter, to pull the signals off of the processor. And as a reminder, those signals that I was pulling off, just pulling up my schematic here on my computer, I'm taking a look at the S0, S1, MIO, and then also that my 4 highest address lines are all high. And so if all of that matches my expectation that A23 through A20 is 1, MIO is 1, S1 is 0, and S0 is 1, then this should light up. And so that matches. I got all these. I have the LEDs reordered so that I'm showing the COD int A, then I'm showing the MIO, S1, and S0. So in this case, I've got MIO is high, or sorry, COD int A is high, MIO is high, S1 is low, S0 is high, and then that is meeting my criteria. And so then I'm getting this to show me that the inverted output of all that is on, and that is pulling down then this chip enable. So if I was to take a look at that, that's this yellow line. And actually it's not chip enable, it's output enable, sorry. So my output enable now is working. The chip enable is the one going to ground, so I always have that. If you watch the last video, just set that to ground. The yellow that you're seeing come across, that is my output enable, so now that is working correctly, and it looks like I have the right indicator. I'm getting the right value out of the ROM. I programmed this ROM with all zeros. I programmed this ROM with all 90s. I'm showing the address I'm at. I'm showing the value I'm reading. So I'm going to call that a win for me for now. Maybe the next step for me is then to figure out, this might be a bad assumption, but my assumption is when I'm at this address, I should be able to read an instruction to jump to, maybe I'll jump to an address that's at the lowest end of my flash ROM, and just let it read NOPs, and that way I should be able to just see it kind of counting up for quite a while as it reads through the entire flash ROM. So that's the next thing I'm going to look into, to see if I can make that happen. For now, I'm going to set this back to auto clock, and I'm going to go ahead and just cycle this. So I'm going to hit reset and let it run from the beginning. So we get there, it's doing its internal reset. When it gets done with that, it should jump to the, there we go, and then it's now counting up through those addresses. It's reading my NOPs, you can see up here, and then it probably gets to the end of my address space, and I probably have problems at that point, errors, etc. I don't know exactly how it's behaving, but it probably rolled over, possibly in what it's reading, I don't know. So that's something I'll have to figure out, but not worried about that. I am just simply happy that I can do this reset, and it does get through and start reading NOPs off of this flash ROM. So more to come. Thanks for watching.